So, according to my notes, where we finished on uh, Wednesday was the bottom of page 2, right? We had just done example 3 in the handout. Are we all in agreement on that? And so we're getting ready to do example 4 on the next page, which is how to find the inverse of a one-to-one function. Okay. And it gives you the 4 steps, right? Write the function in the form y equals f of x, change x and y, solve for y, and then replace y with inverse function notation. And so we're going to do that in example 4. So our one-to-one function is f of x is equal to 3x divided by x minus 4. And we're going to find the inverse function of this one-to-one function. And according to the steps, first step is replace f of x with y. So y is equal to 3x over x minus 4. Okay. Step number 2, switch x and y. Right, so replace y with x and x with y. And whenever we find an inverse function, it's the same 4 steps regardless. Okay? So we're going to find an inverse functions of logarithmic functions and all this stuff later on. It's the same 4 steps. Okay? Step number 3, solve for y. So this is where you're going to use your algebraic skills, right, to solve for y. And you notice we got 2 y's on the right-hand side. And so we got to solve this until we have 1 y all by itself on the left-hand side. Well, for this type, this is actually called a rational function. And for this type of function, the first thing you want to do is clear the denominator. Okay? And then get all the terms involving y on one side and all the terms not involving y on the other side in order to solve for 1 y. Okay? So we're going to multiply both sides of this equation by y minus 4. Okay? Multiplication undoes the division. So we have x times y minus 4 is equal to 3y over y minus 4 times y minus 4. Okay? So just multiply both sides by y minus 4. And you can see on the right-hand side now, right, the y minus 4's cancel. And on the left-hand side, we have to distribute the x inside the parentheses. And so when we do that, we have x times y minus 4 times x is equal to 3y on the right-hand side. And now you can see, right, we got 1, 2, 3 terms. 2 of the terms have a y in it, 1 term does not. Okay. So we're going to bring this term on the left-hand side over, or excuse me, this term on the right-hand side to the left-hand side by subtraction to put it with this term, x times y. And then we're going to move minus 4x to the right-hand side by addition. So it'll be all by itself on the right-hand side. So let's add 4x to both sides first. And we have xy is equal to 3y plus 4x. And now we can subtract 3y from both sides. We have xy minus 3y is equal to 4 times x. Okay. So now you can see we got the two terms with y in it on the left side and the term without y in it on the right hand side. And now you can see y is a common factor in those two terms. So we can factor out a y. And we have y times x minus 3 is equal to 4x on the right. This is a product, right? And so to isolate y on the left-hand side, we now divide both sides by x minus 3. When we do that, maybe I should add some comments up here, okay? So this over here, we multiply by y minus 4. And then over here, we add 4x. Here we subtract 3y. And then we factor out the y. Okay. And now we're going to divide both sides by x minus 3. And when we do that, we end up with y on the left-hand side is equal to 4x over x minus 3. So that's the completion of step 3, solving for y. Right, so that's the equation for our inverse function. Now, the final step is then to replace y with inverse function notation. And so, since our one-to-one function is called f, our inverse function is called f inverse, right? Or the minus 1 means inverse. So we have f inverse of x is equal to 4x over x minus 3. And so that is what goes down here at the very bottom of the page, technically, right? In the space. F inverse of x is equal to 4x over x minus 3. Okay. So it's the same 4 steps every time. Okay. Finding an inverse function. Okay. All right. Now we got to find the domain and range of f of x and the domain of range of f inverse of x. Right? Now we know how to find the domain of a function, right? That was just on exam 2, right? Finding the domain of a function. But finding the range, remember the domain are the x coordinates. The range is the y coordinates, right? So finding the domain isn't that difficult. What's difficult is finding the range, okay, the y coordinates. And so one property from top of page 2, that property of inverse functions, top of page 2, that we often take advantage of, is properties 1 and 2 up here. Okay. The domain of the inverse function and the range of the one-to-one function are the same set of numbers. And the range of the inverse function and the domain of the one-to-one function, f, are the same set of numbers. So if we know the domain of the one-to-one function f, we automatically know the range of the inverse function. And if we know the domain of the inverse function, we automatically know the range of the one-to-one function f. So we take advantage of that relationship. Okay. So on the previous page, let's see if we can remember how to find the domain of a function. Well, f of x, there's no square roots, right? But we do have x in the denominator, right? So the domain for f of x is in inequality notation, the denominator can equal 0. And then when you solve for x, you get x cannot equal plus 4. Right? So x in f of x, or in the 1, 1 function, right? The domain is all real numbers except for the number 4. So in any interval notation, that's minus infinity to 4 parentheses union left parentheses 4 plus infinity. So that's the domain of f of x. So what's the range of the inverse function? The range of the inverse function is the same set of numbers, only they go with y, not x. Okay? Goes with the y coordinates. So the range of f inverse is equal to the domain of f. Well, the domain of f is all real numbers except for 4. So that is the range of f inverse. All real numbers except for the number 4, except these numbers don't apply to x, the input variable. They apply to the output variable, y. Okay. So y can't equal 4 for the range of the inverse function. So the domain of f of x is all real numbers except for 4. The range of the inverse function is all real numbers except for the number 4. Except from the domain of f of x, that's x can equal 4. And in the range of the inverse function, that's y can equal 4. Okay. Any questions on that? Okay. Now, the domain of the inverse function, we know how to find the domain of a function, right? There's no square root, so we don't have to worry about x under a square root. But this is a rational function. We've got x in the denominator. We got to concern ourselves with those values of x and make the denominator equal to 0, right? So we can write the domain in inequality notation as x minus 3 can equal 0. And then when we solve for x, we get x can equal 3. So the domain of the inverse function is all real numbers except for the number 3. And in interval notation, that's minus infinity 3 parentheses union parentheses 3 infinity. So this is the domain of f inverse of x. So that's what goes right here. Okay. Domain of f inverse of x. X can equal 3. Okay. And from that, we get the range of f of x. Same set of numbers, only applies to the output of f of x, the y coordinates. And so the range of f, okay, is the same set of numbers. All real numbers except the number 3, but they apply to the output variable, y. Y. And so that's what goes right here, the range of f of x. Any questions on that? On the relationship between the domain and range of an inverse function and its one-to-one function? All right. So you flip over your page. We'll do one more. Then you'll have everything you need to successfully complete the WebAssign homework. This one involves the square root. So we have f of x is equal to the square root of 2x minus 3, right? The minus 3 does not go into the radical. So same 4 steps for finding the inverse function. Okay. Place f of x with y. Switch x and y. Now solve for y, right? So we're going to add 3 to both sides. Get x plus 3 is equal to square root of 2y. And now, you know, squaring undoes square root, so we square both sides. And now you divide both sides by 2, and when I switch the 2 sides, I get y is equal to 1/2 times x plus 3 squared. Divide or multiply, maybe better to write it as multiply by 1/2. Division by 2 and multiply by 1/2 are the same thing. And then the last step is replace y with inverse function notation. So we have f inverse of x is equal to 1/2 times x plus 3 squared. Well, you should notice that our inverse function is a transformation on the squaring function, x squared, whose graph is a parabola. And parabolas are not one-to-one functions. So it appears that we went from f of x being a one-to-one function to its inverse not being a one-to-one function, and that's not possible. Okay. So we're going to find out, that's why we have this domain range relationship. we're gonna find the domain for our inverse function is not all real numbers. Okay, it's restricted. Okay. So, this is what goes down to the bottom of the page, right? This is our one-to-one function. Okay. This is our, our inverse function. 1/2 times x plus 3 squared. And now let's find the domain and range for f of x and f inverse of x. Okay. All right. Well, finding the domain of f of x is easy. Okay. We've done this. The domain of f of x the radicand, what's under the radical, has to be greater than or equal to 0, right? So, you set the radicand 2x be greater than or equal to 0. All right, that's a linear inequality. Now you divide both sides by 2, and you get x has to be greater than or equal to 0. So the domain of f of x in interval notation is bracket 0, comma, infinity. Okay. X has to be greater than or equal to 0 in order for f of x to equal a real number. Okay. If x is less than 0, then f of x is equal to imaginary. And we're not interested in that case. So the range of the inverse function right, is equal to the domain of f of x and so the range of the inverse function is the same set of numbers from 0 to infinity, only applies to the variable y, the output variable. Y is greater than or equal to 0. So now we know, right, the domain of f of x and the range of f inverse. Now, we're going to have to take a little different approach in finding the domain of the inverse function and the range of f of x. Okay, normally we would find the domain of f inverse and then apply that to the range of f of x. But, as I said, right, the domain can't be all real numbers, because if it's all real numbers, the graph of f inverse is a parabola, and a parabola is not a one-to-one function. That's a horizontal line test. So on the exam, you had to graph a transformed square root function, didn't you? That was problem number 1. Remember that? All right, you had to graph a transformed square root function. So we're going to graph this one, okay? And so the square root of 2x can be written as the square root of 2 times the square root of x minus 3. So if our original function y equals square root of x, right? So f of x is the square root function stretched by a factor of square root of 2 and then shifted down 3 units. Okay. And so the graph of f of x, so let me do it over here. You know that the graph of the square root of x starts at the origin and looks like this. Okay. And so the domain for square root of x is all real numbers greater than or equal to 0, and the range for the square root of x is all real numbers greater than 0, right? So the x coordinates start at 0 and go to infinity. The y coordinates start at 0 and go to infinity. So we stretch this by a factor of square root of 2 and then shift it down 3 units. So here's minus 3 on the y-axis, okay? At x equals 0, f of 0 is equal to minus 3, so it starts here. And then I don't know exactly where it crosses the x-axis. That's irrelevant, okay? But you can see that the range for our transform function, square root function, right? The y coordinates now start at minus 3 and go to infinity. And the x coordinates still start at 0 and go to infinity. So the range of f of x starts at minus 3, right? The y coordinates start at minus 3 and go to infinity. So the range is y is greater than or equal to minus 3. If you understand transformations of functions, right, hopefully this is making sense to you. This is a graph of the square root function. And this is the graph of the square root function stretched by a factor of square root of 2 and then shifted down 3 units. And so with this graph, you can see the y coordinates start at minus 3 and go to infinity. Y is greater than or equal to minus 3. And so in interval notation, that's bracket minus 3 to infinity. So that's the range of f of x. Right? That's what goes right here. Okay. Minus 3 to infinity. Well, now that we know the range of f of x, we know the domain of the inverse function. Okay. And the domain of the inverse function turns out to be just half of the parabola, okay? Not the entire parabola. Okay. So the domain of f inverse of x is the same set of numbers from minus 3 to infinity, but it applies to the variable x, the input variable. So x is greater than or equal to minus 3. And so that's the domain of f inverse, which goes right here. So f inverse of x, right, its graph, right, this is a transformation on the squaring function x squared. So the graph of f inverse, right, is half of the parabola shifted to the left 3 units and compressed by a factor of 1/2. So this is the graph of f of x. The graph of f inverse, this is minus 3 on the x-axis, and at x equals 0, f inverse equals 9/2, which is like 4.5. And so the graph of f inverse looks like that. Remember, a one-to-one function, the graph of one-to-one function inverse, are reflections of each other across that diagonal line, y equals x. We talked about that on Wednesday, right? That's on page 1 of your notes, bottom of page 1, right? You did an exam. Okay. So, if you reflect the graph of f of x across that diagonal line, y equals x, right? You get this graph right here, which is half of the graph. All right. So any questions on that, ladies and gentlemen? Okay. So in this case, we had to find a range of f of x from what we know about the square root function, and then use that knowledge to find the domain of f inverse. Okay. So there are exceptions to the rule. All right. So you got everything you need for the WebAssign homework. Okay. All right, section 2.9 is on word problems. Oh, you got 2 extra, right? So hang on